Okay, so good morning and namaste to everyone. My name is Kiran Bhavatrai, and today I'll be presenting on correlation as a part of course EDMT 512. This presentation is submitted to our respected facilitator Netra Kumar Mananda at Kathmandu University. So let's begin by understanding how and when correlation is used in statistical analysis. So before diving into correlations, it is important to clarify the research purpose. So if I'm examining or differences between groups or relation between variables, then if the focus is on differences, we use t-test or ANOVA. If it is about relationship, then the correlation or regression is appropriate. So tool will focus on understanding relationship through correlation. So how many independent variables are there? So how many groups are being compared? So these are the questions that help us decide the correct test. For examining relationship, we move towards correlation, and for regression analysis. Okay, so let's talk about differences or relationship. So this the previous three diagram shows the summarizes this well. So for differences, if we need to use t-test or ANOVA, and for relationship we used to calculate correlations or regression. So our focus today is on identifying whether two variables are related or not. So here are some examples. Is there any a relationship between children's IQs and parents' IQ? So if you want to do experiment, or if you want to examine on these things, so if you want to see the degree of social trust related to association membership, is overall growth related to air quality violation, do students who spend more time on exam score better? So for examining this kind of things we use correlation. So these are all about relationship, not causation. Okay, so now what is correlation? Correlation, it is a statistical index showing how strongly two variables are related. So it answers the question like, if I know one variable, can I make inferences about the others? If we can know about these things. So scatter plot is a graphical way to show the relationship. Each point on the plot represents a pair of values, and x and y are single subjects. This helps us visualize trend or patterns. So direction of relationship, correlation can be positive. It means that as one increases, so does the other one. So it can be negative. It means when one increases, the other variable decreases. For example, more study time means higher grade. So this is a positive relationship. It means other also there is another example. For example, so if there is more stress, then the sleep will be less. So this is negative relationship. So the figure here shows the relationship. This one is the positive relationship, and the other one is the negative relationship. So here the relationship is R is 0.85, and here it is -9. So let's talk about strains of the relationship. The strains of the relationship is shown by the magnitude of the correlation coefficient. So if the relation is 1, it's a perfect. If the relation is around 0.85, it is strong. If the relation is around 0.42, it is moderate, and if it is around 0.17, it is uh, weak. So the closer the value to 1 or -1, the stronger the relationship will be. So Pearson correlation coefficient, the most commonly used measure of is Pearson's R, which ranges from -1 to +1. So the sign indicates the direction of the positive or negative. Number indicates the strains. A correlation of R equal to 0 means no linear relationship, but variables might still be curvilinearly related. So there are some properties, some points to be understood about correlation. So coefficient of determination is a coefficient of determinants. If we square the correlation to get R square, the coefficient of determination is obtained. So this tells us how much of the variance in one variable is explained by the other. For example, if R equal to 0.6 and then R square equal to 0.36, it means that 36% of the variation is shared or is explained. So coefficient of determination shows these things. So statistical significance of R. It is important to determine if a correlation is statistically significant. If we use the p-value to decide whether the observed relationship is likely due to chance, this is visually calculated using software like SPSS. So correlation and causation. Correlation does not imply causation. For example, ice cream sales and drawing may be correlated, but both are caused by hot weather. Like ice cream sales also increases by hot weather, and people drawing মানে go ডুবনো can also be caused by the hot water because they might go to the river, and the causation is the same thing. So we always ask, does X cause Y, does Y cause X, or there is a third variable that which is responsible for both of the things. So we can see this using SPSS demo also, that will be uploaded a little later. I will be showing that demonstration here. And then simple linear regression goes beyond correlation. It allows us to predict values. It examines the linear relationship between one independent and one dependent variable. And the example of linear regression can be predict productivity from assembly test score, predict GPA from SAT scores, predict cholesterol from the fat intake. These use one known value to predict other one. So prediction, perfect prediction is with a prediction correlation, perfect correlation. Every values of X aligns with the specific values of Y. In a scatter plot, this appears as the straight line. So though rare, it demonstrates how strong correlation enables accurate prediction. So this is from all my side. Thank you for your time and attention. So in conclusion, we can say that correlation help us understand relationship, regression help us predict, but we must always be careful not to confuse correlation with causation. So I'm happy for sharing this one. Thank you so much.